start streaming. And it should catch up with us in a second. I think that's our new chat. And here's the old one. All right, here we go. Close that. Yes. Well, oh man, do I have... It won't let me turn on captions live right now, but there will be captions. Sorry. I'll have to mess with settings to see if I can get captions up too. Sorry about that. Oop, CE, no, ME. Okay, first off, welcome to ME2120. Do we know what class this is? Other than the number, the alphanumeric thing. What is this? Applied Mechanics 2, cool. So Applied Mechanics 2. Apple Mech 2. Why do you need a second one? Why not just go with Applied Mechanics and cover everything? What is Applied Mechanics 2? Are we frozen? It'll catch up in a second. Yeah.
This Applied Mechanics one was just statics, but this one will have dynamics.
Okay, so static versus dynamic problems. I like to call this course like engineering dynamics or dynamics, like studying motion. Dynamics is split into two main parts. And do you already know what they are? I don't think so, because this is your first dynamics class. But I'm gonna split the class in half. I'm gonna split like the stuff that we learn right in half and say there's only two things that we're learning. Oop, if I could spell. There's kinematics and then there's kinetics. And that's it. See you in 15 weeks for the final. No. So take 2 minutes, talk to each other. You can look on your phone like this is not a test. But what is the difference between kinematics and kinetics? Why split that up? Other than the fact that I'm a pedantic academic and I love to classify and organize things. So what do you think? Why do we have these two things? What's the difference? right. So, hey, we're back. I know sometimes I gotta like, it's the best part of like asking questions when everyone's like, stop, I'm still talking. I'm like, I know, that's the point. It's exciting and we're into it. Okay, so some things that came up, at least from quick interactions that I had. I didn't talk to everyone in the class, but there was, people brought up kinematic equations from physics. What were those? What was kinematic equations? What did that describe? Yeah.
Acceleration.
Okay.
Position.
Acceleration, velocity, and position. Cool. What else came up? Yeah.
So it's more concerned with motion and the forces that cause it.
So it's motion. So then you think kinetics is forces. How do we feel about that distinction? So is a kinetic energy, is that a force? Or is it just a mislabeled energy? The island of misfit energies. What do we think a kinetic energy is? Yeah.
Energy, but caused by motion.
Energy caused by motion? So can we have kinematics that create energy?
Well, not like created.
Okay, yeah, not created. Not created. You can't create energy, right? This is rule number 1, don't create the energy. Like, you get what you got. Rule number 2, you can't win. It's a thermo in a nutshell. So motion. Yeah.
Is it energy that causes motion?
Energy causing motion. Oh yeah, motion. Energy causing motion, maybe something like that. So we came up with the same thing twice. Yeah.
I was going to say, is energy stored by motion?
Energy stored by motion, or stored by how do we think? Storing energy, causing it, like causing motion. Is this a good do we have a distinction, or are they all kind of the same thing right now still? What else came up? Some people Googled it, at least when I was walking around. What did Google like tell you exactly what you needed to know? Yeah? Did Gemini like totally deliver? What did Gemini tell you? Because usually that's the first it's a Gemini result, then it's an ad, and then below that is an actual, well, probably a Reddit post, right?
So I saw that it's how versus why.
How versus why. Okay, I like that. Which one's the how?
How is the kinematics.
How is kinematics,
How objects move, and why is the kinematics.
and then why they move is kinetics. What do we think about that? Nobody disagrees. It's like Gemini knows all. It has all of my information. It knows exactly what I want. So it's going to deliver me the right information.
It's like, is it like, kinematics is like the coordinates, like the, I guess like geometric stuff.
Okay.
Where things are, how things are moving, and then kinetics is like the forces causing that, like gravity, torque.
So kind of like two buckets. We could put one as, man, we're lagging today. I didn't pause it, did I? see if that catches up. So we could put a bucket of geometry and then a bucket of cause of geometry. How does that sound for kinematics, kinetics? So I can tell you at least kind of a good working definition of the two. Kinematics is the kind of general study of what is the geometry of motion. So we already kind of mentioned its position, that's velocity, its acceleration. It also has to do with like, what is position? How do I even define the fact that this thing is moving around on a sphere that is the Earth, right? Like, okay, I need some kind of latitude, I need a longitude, some kind of constant radius. No, that's too complicated. I'm just going to say it's all two-dimensional. It's all moving in one plane. But those choices that you make, those are all kinematic choices. Like, is it a vector? Is it just a magnitude? Can I just describe like how far it went? Or do I actually need to know, is it moving up and down? All of that is like describing geometry of motion. Nope. And then kinetics. I kind of like to say it's like the why or the how motion occurs. So I disagree with Gemini. I know, like fighting with a robot, losing battle. But I think kinetics is more of like why and how, why or how, like something. So something accelerated by 9.81 meters per second squared. It's like that was probably from the force of gravity. It's falling. And that's like the cause of like how did it fall? Gravity pulled it towards the surface of the Earth until it hit the floor, and then the egg broke all over the floor, and now the 2-year-old has moved on to other activities like Legos or something, leaving the egg with the impulse cracking it. So the why or the how. I use why and how because a lot of dynamics is like physics. Like, why does this motion occur? The how is really, as engineers, of like, how did it occur? How can I change it? How can I optimize it? Usually that's kind of the questions that we're asking. Do you have issue with these definitions? You can. It's not Gemini. I didn't get this from Gemini. This is just like years of experience of dynamics and engineering kind of work. Okay, now we're done. Now we know everything we need to know about dynamics, right? Just split it into one of the two and move on. Yes? No? Maybe? It would probably help to know like how to use it rather than just like that it exists. So maybe we could do that. That usually takes the bulk of our time, right? It's like, yes, I know position is a vector, but that does not help me get to the point that it creates an equation of motion for me. Like, and that was one thing that did come up, equations of motion. Where do those fit? Like, how do you get to an equation of motion? And what even is that? What is an equation of motion? Do we know? Yeah.
If there's a few known values you can solve for another, do you think that
Could it
describes how
be any like algebraic equation though?
it's an equation that describes how an object moves.
Just in general, or specific?
Yeah, I think it's like a general equation for
General equation?
all cases.
For all cases. Okay. Yeah.
Are you asking for equation or what do you?
Sure, yeah, we could throw it. What is an equation of motion? Yeah.
D equals V naught plus AT.
Okay. D equals V naught plus AT. What is this equation of motion telling us? Yeah.
The velocity of an object at time t.
Okay, so this is not constant. This is some velocity as a function of time. So it's a function. And then it's equal to initial, v0 initial, like v at time 0. Okay, plus at. What does at have to be? What does a have to be here? Acceleration. What does acceleration have to be? I know this was like, it's an equation of motion. Like I remember knowing these equations of motion, just knowing that that is motion. That's, by God, I'm going to use this equation. If there's motion, it's got to be an equation of motion, and I'm going to use that equation. But what has to be true for this to be true? Do you know what I'm asking? Yeah.
The acceleration has to be constant.
Constant acceleration. Yeah. So A has to be constant. When is acceleration constant? So we're getting out of the realm of kinematics into kinetics. How can I keep A constant?
Gravity is one example.
Okay, gravity is one example. Is it constant as we go to the moon?
Not quite.
Okay, not quite. So what happens? Why is it constant here in the classroom?
Force is constant.
The force is constant? Because, yeah, so gravity is like that special case of, right, like 1 over r squared. So so if radius is roughly always the radius of Earth, then it becomes a constant g. So F equals mg. So F equals ma. F is constant. So if F is constant, then this holds true. So for a constant force, yes, there's a constant acceleration, and velocity is always linearly increasing, decreasing, whatever. It's got some kind of slope. All right, but that doesn't, is like a pendulum, does that have constant acceleration? Is that a good example? Kids these days, you haven't seen pendulums. Back in my day, we used to watch the grandfather clock tick down the school day. Not really. I didn't have a grandfather clock. We had Casio digital watches and Game & Watch, classics. But, so we had to watch the quartz vibrate back and forth until class could finally get let out. So what happened? So how do we come up with what's an equation of motion for something that doesn't have constant force? What happens there?
Well, the acceleration can be written as another function.
We could have some kind of function of acceleration, right? The general answer to this is that usually, so this, like when you're kind of taught like, hey, this is an equation of motion, it's skipping a lot of steps. Really, the equation of motion was that A equals G. That's where you started with. That A is constant and that constant is G. The solution to that equation of motion is the equations of motion. Like here, you can integrate it 2 times and get position. You can integrate it once and get velocity. So we kind of brush that stuff under the rug to get like an idea of like how does motion occur. There's 2 dimensions of motion. It's a vector. Vectors are, we can split those vectors into x and y components. But really for this class, one of the main things that we're trying to do is separate out our kinematic and kinetic knowledge so we can combine them as F equals ma and come up with something like A equals G, or A equals negative kx, or some kind of like, what is the equation that is constant while this thing is moving? Head explodes. So let's take, sorry, lost. There we go. Okay, so that's kind of like what this class is about. Now, so that's like the kinematics of the class. Like you're gonna do this stuff whether or not you know what it is. You're just gonna follow this route that was carved out for you. So the question for today is take a minute, talk to each other. And so first off, let's do a quick poll. Who is here because this is a required class? Is this 100%? Does anyone have this as an elective? Yeah, nice, you made it. I know, sorry, you don't have to like keep it up. I don't want to single you out, but thank you. So 99%, there's 100 of us here, 99%, it's all required. So I know it's required, but besides that, why would this be required? Like why learn this stuff for engineering? So take a minute, talk about it, and then we'll share out reasons to actually learn this stuff. So why are you here? All right. Welcome back. So, at least I grabbed a couple of things that I had heard. One of them was kind of like, okay, statics is your intro. F equals 0. The sum of the forces is 0. So now you get to do the other half of F equals ma, and you need both. Like, no matter what you do, you just need both. And so some people kind of justify it with, like, if stuff is moving fast, things are different. Maybe we don't know how they're different yet, but they feel intuitively different. And then someone else kind of justified that with, like, everything is either moving or vibrating. Like, something, there's always motion around, like even in a bridge. Classic example. I got to see this last summer, the Tacoma Narrows bridge, at least the rebuilt one. I didn't get to see the vibrating Tacoma Narrows bridge. Have you seen this video?
Yeah.
It's required. Like, as an engineer, you have to watch it at least, like, I don't know, 50 times before you can get your degree, because it gets introduced in so many different courses. And then you can finally, like, okay, you've seen it enough times, now you have your degree. So that's your homework. If you haven't seen it, Galloping Gertie in Tacoma Narrows, like, go find it. It's a crazy video of this bridge, like, vibrating. What else came up as you were thinking about, like, why are you here? Like, what is dynamics? Why be here in this classroom? Anything else come up? Yeah. To graduate, okay. What is graduating going to give you?
Degree.
What does the degree get you?
A job.
How does your degree get you a job? Which one? You think any engineering degree will get you any job? Or there's always a demand for engineering degrees? Has anyone been on the job market lately? Have you been applying for jobs lately? It's rough out there. What do you think?
It proves to a company that you have some skill.
Okay, so the degree is maybe some measure of skill. One thing that I like to do in this class, and I'll get into, right now there's no, like, logistics of this class. I don't have a grading scale yet. I don't have, like, what assignments we're gonna do. I am totally unprepared. I was kind of blindsided with, like, how different things were going to be this semester. I mean, I kind of saw it coming. I just didn't know how to plan for it. So now here it is, and we're gonna roll with it. So one of the things that I really like to do is give, at the end of the semester, some kind of individual project where you do you identify a problem, do some research, define, like, what are the constraints, what are the forces that are involved, and how does that lead to maybe an equation of motion or some kind of geometry of motion, and then you describe why is that important. It's not a master's thesis. Like, you're not trying to create, like, a new scientific endeavor. It's just taking F equals ma and doing some math to get some insight into, like, how the world works. Either reverse engineering something or kind of figuring out how to do something new, something like that. The thing that's nice about that is it changes, like, this idea of the class of, like, I took this class, I'm an expert because I took the class, of this circular logic, right? Like, they told me to take the class, some expert told me to take this class, so I took it, I got an A, now I'm an expert. It's like, well, no, you just did what the expert told you to do. Versus, at the end of the semester, I took 2 weeks. I was really interested in how guitar strings work and how tension is used to tune a guitar. So I looked at wave vibrations in a string. It was a little outside the scope of exactly what we had covered, but it definitely was dynamics. And I came up with some governing equations of like, what is the natural frequency of a guitar string? Like, that's a great story that you can use to now talk to people that are interested in vibrations, like aerospace companies or car companies. So trying to change that perspective of like, this class is required, so I have to take it because I need that degree, versus I'm doing things to enrich myself because I have this career that I'm looking for. So that's what I really like about this class, and I love that like end of the year kind of change of like when you get to guide what you want to work on. As we're figuring out what we want to do this semester, so part of this is figuring out what you want to do. We'll figure out how to fit that in and what's most important. Anyway, that was a long explanation. That was me saying, why am I here? Any other reasons why you're here? All right, we'll do a quick segue into, there's not much that we have ready for the class, but I'll show you resources that we have so far. I'll post a link to my website on Husky CT in the next couple of days. Why is this so slow today? It's catching up. It'll catch up. So main thing on my website is office hours. So Calendly, you can schedule like half-hour appointments if you want to meet and talk about, and it could be stuff of like, how do I use this class? Like, I'm interested in this career. How do I actually apply this? The YouTube channel of like how to get to these live streams is also here, and there's links to like ME2120. You can watch even previous year's lectures or the current lectures, even other classes if you want. And then right now, this is still like the fall 25 syllabus, so it's not our syllabus yet, and we'll figure that out. Like by next week, we'll have a set thing that we all agree on. But it does have some resources, such as the main thing would be like textbook. The UConn library has our text that hosts our textbook, so you can download all the PDFs from online, and yeah, so you don't have to buy it. And then it does have like modules and kind of general like idea, like course content here on the website. We'll restructure how we are getting credit for the work that we're putting into the class. At least by next week, we'll have an idea of that. How are we doing? We have a couple of minutes left. I heard some people packing. Are we done? What time? No, we still have a couple of minutes. All right, cool. So in terms of questions on getting in contact or getting to course, like the course textbook, and right now it's like links. Click on a link and then it should get you there. But I'll share that, like the main like Professor Cooper link. Good? Cool. So for next class, what I want you to do is figure out like what are we kind of figured out like getting a degree and kind of getting this information and moving stuff, like things that move is important. at least some people identify. Maybe you don't agree. Maybe you think like the world is static. I don't need to learn about motion. If that's true, let me know. I'm not going to try to change your mind, but I just want to know what are you doing and what do you want to do in the course? Like we still have another 14 weeks. So to get a degree, but so what are the things that bring us to class? Like, is it stuff that we work on together, example problems? Should we just like do exams, like show up for exams? People love those. I hate exams. I can't stand preparing them, administering them. Normally I just do no exams, all projects. So I'd prefer no. But if there's an overwhelming, like we'll see you every 3 weeks, we'll do an exam, then we'll call it. Like we can do that. I just don't think there's a lot of like learning that happens that way. So I'd rather do stuff together. Yeah. So the live stream this live stream is recorded, so you can go through and kind of see these notes there. But I don't usually like also post the notes. It's just like an extra burden of like now I have to export to PDF and then put it on a website, and so they are there. You can access them. They exist. So for next class, what are the things that we want to do in class that are going to keep us coming here and learning together? So I like projects. In the past, what I like to do is like build quizzes together, like take some brainstorming time and figure out what are the things that we have covered, what are important concepts, build a quiz, and then you get some time to kind of do that quiz, or even like group work of some kind. So next class, we'll brainstorm and write down what ideas we have, and then by next Monday, we'll have kind of a plan of like, this is how we're going to attack the semester. Sound like a plan? All right, let's do it. I'll see you on Friday.